So we've got a nasty rainy day outside and I can't do anything with the bees. So today is the perfect day to build a new heated bottling tank. A heated bottling tank is rather expensive from any of the honey equipment suppliers. So I found a way to build my own honey bottling tank that's a lot less expensive, more compact, easier for me to use. And to do that, I start with a Digiboil 35 liter or 9-gallon electric brew kettle. So this is meant for brewing beer, but I won't be doing that with it. What I'm going to do is I'm going to take it apart. I'm going to rewire it to reduce the wattage density of the heating elements. And this will provide a more gentle, even heat for honey. And it's going to allow me to use this as a honey bottling tank instead of a brew kettle. Before we get started, I wanted to gather up all the tools and supplies that I'm going to need to build the heated bottling tank. So I have some cable ties. I have some heat shrink wire connectors. I have some heat shrink tubing. I have a multimeter, simple multimeter, little lighter to heat the heat shrink. We have Phillips screwdriver, straight screwdriver, a pair of wire cutters. There's a wire stripper and crimper. We have a soldering iron, some flux, some electrical solder. We have some 16 gauge wire. I just grabbed two different colors. I got a red and a black that I can use. And then I have some drill bits, a drill, and a piece of sandpaper. And then the equipment that we're going to be putting together along with the tank. We have a heatsink for a solid state voltage regulator. We have some screws for that voltage regulator to attach it to the heatsink, along with some heat transfer paste. We have a rheostat that is sized for 120 volts and this particular solid state voltage regulator. And these are some pieces that go along with the rheostat so that we can have an adjustment knob to be able to turn the power up and down. And then over here we have a asymmetrical timer. So this allows us to control how long the electric is going to be applied to the heating element, and we can control the pause in between as well. So this is one of the nice things I added in my most recent build to sort of even out the flow of heat to the honey when you're heating up a tank from cold. So you've just dumped in a couple buckets, and it's kind of nice to let it slowly heat up because the more gentle you heat the honey, the less chance there's going to be from any scorching or discoloration or anything else. So opening it up, we have the lid, we have a handle for the lid that needs to be assembled, we have some instruction manuals, and we have a valve. So I don't need any of that right now, so I'm going to lift this out of the way, and we're going to set this aside for now. And then here we got the brew kettle itself. So I'm going to pull the brew kettle out of the box, and then I'm going to sit the brew kettle down on the table. And I've laid out some packing blankets on one of these plastic folding tables, and that's just so I don't scratch anything up. Okay, so I'm just going to take off the wrapping carefully. And here we have our brew kettle. We got the control panel. We got the switches for the two heating elements. And we have a general power switch. This is a spot for our valve. And we have an electrical cord in the back. I'm going to free up the electrical cord because I want to be able to plug this in and test it out. I want to show you not only exactly where to wire it, but how to go about thinking about rewiring it so that if you end up with something different yourself, you might be able to figure it out. So now that I have the brew kettle, take it out of the box, ready to go, I'm going to take this cord. I want to plug it in while I'm working on it. And I'm going to drape the cord over here. I have some packing blankets set up. They're kind of folded to make some little pillows to keep the end where I want it to be. And this will keep it steady, keep it from rolling off the table, and give me plenty of room to do my work. So I have an extension cord running from the wall. I have my cord for the brew kettle. I'm gonna make sure it's off first, and I'm gonna make sure the two heating elements are both off as well, so I don't want it heating up dry. I'm gonna go ahead and plug it in, and then I'm gonna make sure that we got power. Okay, we do have power, so before I waste my time rewiring a unit, I already know that it works. It's registering 17 degrees C, and I believe to switch that, I think I have to hold both of these down, and boom, it's now registering Fahrenheit. So 63 degrees Fahrenheit. Temperature seems correct to me. I don't have to worry about having a defective unit from the start. Just real quick, I'm just gonna flip this on, and I'm gonna raise the set point up. Just put it up to 68, okay. Pops on, 1000 watts is working. 500 watts is working. All right, so both heating elements are coming on. They're transferring power, and this thing is working and ready to go. So let's take it apart. All right, so reaching for my first tool, I have a Phillips head screwdriver, and I'm just gonna very carefully apply some pressure and remove these machine screws. Be careful that you don't strip the screws. So make sure you're pushing in while you're turning, and use a screwdriver with a good tip. And this is, these are stainless screws, and it's going into a stainless backing. It's pretty thin tabs that the screws are going into. So it is important not to gall stainless when you're screwing stainless into stainless. You can strip out the threads really easily. So I recommend using hand tools only. I wouldn't use a power drill. You don't want to move too fast and generate too much heat. All right, so with the bottom unscrewed, that plops down even easier than I expected. And so here we have the bottom of the unit. We have the controller right here. We have our power coming in. So we have two wires. One of them is going to be the common, one of them is going to be the hot. We have a ground connecting here to the unit. Then we have our two switches right here, and we have our main switch right here. And I'm going to be careful not to touch anything on the metal because it is plugged in. Some of it could be hot. Okay, so I have my multimeter set up. This is the power cord coming in to the bottom of the brew kettle. I noticed this top wire right here. You can barely see the white in there on the shielding on the wire. So that is, or the insulation rather. So this is the common wire, and then this is our hot wire. And you can see that our hot wire is running over there where that red one is attached. This power is live right now, so I'm gonna be careful with my fingers. I have the meter set up, so what I'm gonna go ahead and do is just confirm that I do have power to it. So I'm gonna touch the red tip to my ground, because my base is grounded, because ground wire is attached over there. And I'm going to touch right here to this terminal, and I can see that I have 123 volts. So that is our line power. So that's the hot coming in. If I touch this, I don't have anything. Okay, one of the next things I'd like to do is assemble the heat sink to my solid state voltage regulator. So I have two of my screws, and I have some thermal paste right here. So I'm going to go ahead and open up this thermal paste. And I'm going to squeeze this out, and I'm really going to try to cover all of this really good. So what the thermal paste does is it helps transfer heat between these two pieces of metal. Invariably there's going to be some sort of void space, and heat doesn't like to travel through void space as well as it does when there is contact. So the thermal paste is providing good contact with thermal conductivity to dissipate the heat generated by the solid state voltage regulator. So I think this is pretty good. Any excess is just going to squeeze out when I go screw it on. So cap back on here. I'm going to line this up. up. Very carefully position my screws. Okay, so this one's snug. Not making it super tight yet. Let's line this one up. And just wiggle this around a little bit, make sure it smears out the paste. All right, and just like that. So now that we have both of them in, I'm going to snug this one up, give it a little bit of torque, but I'm going to be careful about tightening it up too much because this is an aluminum heatsink, and this zinc plated screw is stronger than that aluminum, and you might strip out your aluminum if it's too tight. So there we go, nice and finger tight. All right, so now the solid state voltage regulator is mounted to my heatsink. So now I have my rheostat, and I want to get the rheostat attached to the bottom plate. When I built my first bottling tank in this manner, I decided that rather than drilling a hole on the side to have the knob up top where I could reach it, I really didn't need to adjust the knob very often. So what I wanted to do is put it in the bottom. And there's this nice little hole here in the bottom. It's just a little bit too small. So this is something that it's already piloted there. I can drill it out larger. I can put the knob for the rheostat through, and I'll have a control on the bottom to adjust the heating anywhere from 10 to 100% of the available capacity. So let's get this drilled out and get the rheostat mounted. So I've eyeballed up the threads of this to this bit right here. This happens to be 25/64, so it's just a little bit larger than 3/8. So I'm going to go ahead and I'm going to grab the drill, and I'm going to grab my plate, and I'm going to drill from the bottom of the plate up so that I have the rough side on top. All right, so I'm going to go ahead and just start drilling here. Now I'm just barely putting any pressure. I want to go really nice and slow. Oh, and there we go. Now I'm going to reverse it. I'm sorry. Make sure you can see this. Okay, so it looks like we have a good clean drill all the way through. So this is where the sandpaper comes in. Notice how there's a little bit of a lip there. So I'm just going to take the sandpaper. And this is the inside that we're not going to see. So I don't mind scuffing this up just a little bit to get it flat. So now that we have our hole drilled out for the bottom plate, and I have my rheostat here, I can slip that in and make sure that fits nice and snug. It does. I'm going to have to bend those ears down so it goes all the way. But until then, I just want to be able to size up the amount of wire that I'm going to need here. So when I have my solid state voltage regulator in place, I'm going to mount it in here, and I'm going to zip tie it in between these two posts. And I'm only going to zip tie it in as opposed to mounting it in a more professional way, just because the zip ties are easy. I found they held up well. It's not UL approved, but I'm not selling these. I'm just using it for my own purposes. So I have the bottom plate here, and when I remove the bottom plate, I want to have enough wiring so that I can slide the bottom plate out of the way. So I'm going to put the plate about where I think I would put it if I have to take this apart in the future or while I'm assembling it together. And the two terminals over here on the solid state voltage regulator is where I need to wire over to the rheostat. So I'm going to grab some wire, and I'm just going to estimate this over here. Looks like I need about this much wire. It's not a whole lot, so I'm just going to pull out a little bit more. So I think about like this. This gives me a little bit more space. All right, so I'm going to go ahead and bend this here. I'm going to pull this wire out. Stretch it over here. All right, so this is going to give me 2 lengths of wire, same length in the length that I want. So now I just need to go get my wire cutters, and I'll cut this right here. Okay, so I'm back with the wire cutters. Just going to make a cut here. I'm going to come up to the other end, and I'm going to make a cut here. All right, and now I have my 2 wires that I'm going to need to connect the rheostat. Okay, so this is 16 gauge wire that I'm using, and now I have my wire strippers, and I'm just going to want a little bit of wire exposed to be able to solder to the rheostat. So I'm going to line that up with the 16 gauge, and I'm going to pull off some insulation. I'm going to do the same thing with this one. I'm going to try to get it about the same length. Let's see if I can get that on the first try. There we go. All right, so now I have some wire that I can solder the rheostat. The other side, I'm going to need to wire into my solid state voltage regulator. So I'll go ahead and strip these as well. Okay, 1. So this aside, and 2. Okay, my wire's cut. I'm ready to start soldering it to the rheostat, but where do I solder it? So what I have here on my phone is I have a wiring diagram showing how I am supposed to connect this. So if I look, this is a 40 volt solid state voltage regulator that they're showing. But what they're saying is that pin number 3 needs to be connected to this terminal, and pin number 2 needs to be connected to this terminal. And then the ground goes to that terminal. Now I'm not going to worry about the ground because the ground pin is going to be pushed into the bottom, and that is going to be screwed to the rest of the thing, and it will be grounded. So I can ignore that for now. But what I do need to know is that I need to know what pin 3 and pin 2 are. So if I look at it here, I'm looking at it the same way. So I have pin 3 goes to this terminal right here, and pin number 2 needs to go to this terminal. Let me bring this over here. So if I pull off the cover, we have this pin here and this pin here. So this terminal needs to connect to pin number 3, pin number 3 on the rheostat, and this terminal right here needs to connect to pin number 2 on the rheostat, and I can ignore pin number 1 in the ground. Okay, so I'm going to go ahead and get prepared to solder these wires to the rheostat. So I'm just going to twist the wire around a little bit. This one is going to go up into terminal 3. So I'm going to take that up in, and I'm going to fold it around. Just going to twist it around. All right, so I'll be able to solder that on. And then the other wire, I'll do the same thing on this end. I'm going to twist that just so I can get this up through the terminal pin. All right, so both those are on nicely. All right, so now it's time to solder. Okay, so I have the soldering iron heated up, and I'm just going to take an old cookie sheet, and I'm going to sit this on top of the cookie sheet because I don't want to set my little packing blanket on fire. I'm going to need the flux, and I'm also going to need the solder. So just want to make sure this didn't get moved. Still put around that way, and this is still around this way. Okay, so I double checked the wires there to make sure they're in the position that I want. I'm just going to get some flux out of here, and just going to put some flux on there. I don't care if it's too much. You need the flux to make a good solder. All right, so I'm just gonna get that on there like that. And then I'll just leave some of the flux on the end. Now I'm gonna take the soldering iron and I'm just gonna melt. Now I wanna be very careful not to heat up the rheostat. So I'm going to make a blob of the solder and smear it onto there, okay? And I'll do the same thing over here. All right, blob of the solder. And just smear it on. Okay. Careful not to heat up the rheostat. And then for good measure, I'm going to turn it around. And I'm going to make sure I got the other side. Other side nice and coated. But I'm going to be careful about not generating too much heat here. And I like to see a little bit more on here just to make it a little bit stronger. Okay. All right, that to me looks good. Put the soldering iron down. Just gonna check, make sure nothing's loose. This is perfect. I have pin 3, pin 2. So something that you don't have to do, and I don't have to do, but I'm probably gonna do it anyway. I'm gonna take some heat shrink and I'm gonna put over this and just make sure that nothing shorts out, because this will be in close proximity to the bottom here. So I found that this heat shrink tube fits over my little knuckles of solder. So I'm just going to take my wire snips and I'm going to cut this. This is the perfect length to cover that up. So I'm going to slip these on. Now I did take a paper towel and I just cleaned up carefully some of the excess flux, just to get that off of there. Okay, so now I have the 2 pieces of heat shrink slipped onto here, and I will carefully shrink those up. Looks like the lighter's acting up. All right, so that looks good to me. I can color code. So I'm going to take 2 pieces of this. All right, so I'll make terminal 3 red. Slide it up over that. Terminal 3 black. That one slid up a little bit easier than this one. So it looks like I need to shrink that one down a little bit more. There we go. All right. I have, this is the other end of terminal 3 that I wanted to label red, signify red, so I'm just gonna put that over here and I'm just gonna shrink this down. All right, so we have my red band. And then I'm going to do terminal 2 real quick. I'll make this one black on the other end. Wire's already black. It's a little superfluous, but we'll shrink that on there like that. Okay, so to try to keep the wire a little cleaner, what I'm going to do is I'm going to take some pieces that I cut, some shrink tube, and I'm going to thread both wires through. All right, so I got one piece, two piece, three pieces, and here's a fourth. So now, I'm just going to space this out. I think it looks pretty good. Move this out, make sure they're not twisted. All right, so now we have the wires kind of cleaned up a little bit more. Okay, so now with the heat shrink in place, my wire's tagged for which end is which. Cleaned up a little bit with some shrink wrap in between. I'm going to go ahead and mount the thermostat or the rheostat on the bottom plate. Now I have these two tabs right here that are sticking up. I'm just going to use my straight screwdriver and I'm just going to bend those over. All right, so now I've got those bent over, and now I want to put the rheostat up through. So I'm just going to sit this on the table here. So I have the rheostat coming up through. I'm going to put my dial on here. So this is the scale, and this is how it fits in there perfectly. It's like this was made for it. I have a little washer here to drop on. And then we have a little lock nut. So this lock nut is going to go on here. There's not a lot of threads, so it's a little harder to thread on. And I want to be careful not to cross thread it. So everything's got to feel very smooth. Okay, perfect. All right, so that's going on. Okay, so I'm ready to put the knob on. So I have my knob. I'm going to line it up to just a little bit ahead of 0, since I expect it to kick back a little bit as I'm trying to tighten the screw down. All right, so now I've got it just about 3%. Tighten it up a little bit. To kick back, yep, it kicked back a little bit less than 0. And it looks like it only spins up to about 96. So this thing isn't, you're not anything very precise with this. I usually leave mine about 10 to 12%, so I'll just adjust it to there, and that's where it'd be. If you take it out any less than 10, puts a little bit more stress on the SCR, and you may find that it will kick out and stop working, and basically it'll just kill the power to the unit, and you won't have any heat. So then you have to cycle the power off and back on. But if you keep it up about 12%, there's no issues. And you can take it anywhere from 12 to all the way up to 100% if you want to heat up something really quickly. So if you're emptying your honey and you want to heat up some water in it to clean the tank out with some hot water, you can go to the bottom. Once you've emptied the tank, crank it all the way up, heat up your water, clean your tank out, and then make sure you set it back down to give you a lower gentle heating once it goes back to heating your honey. So I am ready to wire up the solid state voltage regulator to the rheostat. And let's recall that we have pin 3 here that we marked red, and we marked it red on the other end of this wire. And if we go back to our electrical diagram, we see that pin number 3 is supposed to be connected to this terminal right here. So let's go ahead and do that. Take the Phillips screwdriver. Just going to loosen this up. Go ahead and loosen this one up as well. All right, so I want to be able to slide this one under here. I want to make sure that I'm not clamping down on the insulation of the wire. I'm just going to snug that up. There's no current traveling through here. This is just to provide some resistance, like you'd have a resistor. So there's no concern about cranking this extra tight. You don't want to crank it too tight and end up damaging your solid state voltage regulator. Check that. Check that. All right, so that's good. All right, so now we got it wired up. So now that the solid state voltage regulator is wired to the rheostat, the rheostat's in the base, we have our wiring for that taken care of. Now it's time to wire up the power to the solid state voltage regulator, and I want to throw in this timing unit as well. So I have the electric kettle plugged in. So I have some hot wires in there right now, and what I want to show you is to find where the power is being applied when the heating comes on. So if I turn this on, and I have both of these switches for the down here for the 500 and 1000 watt heating elements. I have both of those switches turned off, so it's not heating anything right now. But if I were to flip them on, then the heat would come on. So right now, it's about 65 degrees in the garage here, and I have the set point set for 63 degrees, 62 degrees, so it's not coming on. So if I take my multimeter and I go from ground, I'm looking for where the hot is. So this is the hot coming in. So we have 120 volts right there. This is our common, shouldn't have anything on this. Don't have anything on this right now with it powered up. And I don't have anything on this terminal right here. So what I'm going to do is I'm going to raise the temperature set point. (67 degrees), so it's kicked on now. So now it's putting power. And if I check this fourth terminal right here, now I have 120 volts, or 123 volts. So you can see that power from this terminal is going to these switches, and then from these switches you can see that it's going back in there to the heating elements, and then coming back out the blue wire to the common. So this is the way the power is flowing to the heating elements. The power is coming from this terminal right here, going to the switches. When you actuate the switches, then it's allowing power to flow to the heating elements. So if I want to run the power and interrupt that, I can run it through the solid state voltage regulator and the timing switch. And this is where I need to get the power connected from. So we know that the power is going to come from this terminal right here, and we know that the solid state voltage regulator is going to drop the voltage. But we want our timing switch to see full voltage, so we're going to have to make sure we run the power into the timing switch first, because this is what we want to control the on-off with, and we want to make sure 120 volts is going to this, because that's going to be less amperage. So if we look on the timing switch, this gives us a wiring diagram. And it tells us that this one has two switches that can be wired separately. We have 15 and 25. Terminal 15 and 25 is where the voltage is coming in, and it is switched between terminal 16 and terminal 18. So you have a normally closed and a normally open terminal. So what we're going to do is we're going to wire the power coming in to 15, and we're going to go to 18. And since we have two things, and I don't mind splitting the amperage between the two, I'll go ahead and run two extra wires. I'm going to run a wire to 15 and 25 from the hot, and I'm going to run from 18 to 28 over to the solid state voltage regulator. Then the other side, this terminal right here, this is where we need to supply power to the switch so that the switch can actually switch. So I'm going to need to run, and I only want the switch timing when heat is actually being applied. So I'm going to need to run some power over to terminal A1, and then terminal A2, that's going to need to go to the common. So I need to run 3 hot wires, one to 15, 25, and A1 off of this lower terminal here, and I need to run a wire to the common off of A2, and then I need to run 2 wires over to my solid state voltage regulator from 28 and 18. Before I do that though, I'm just going to take a look at the timing mechanism, or the timing adjustment, and I see here's the settings. So this is the on and then off, the way that I'm going to wire this up. So I want 30 seconds on and 30 seconds off to start with. So I'm gonna carefully set that over to where the arrow is pointed at 1 minute. And for 30 seconds, I'm gonna put it over here to 50% of 1 minute. So that's 30 seconds on. And now for off, I'm going to change it to 1 minute, and I'm going to adjust this one again to 50%. So that'd be 30 seconds on, 30 seconds off. Okay, so let's get out some wire and wire this up. I have unplugged it, so everything is cold right now, no electric. And since this is where I want my power to come out of, I'm going to go ahead and I'm going to pull this wire out of here. All right, and we have a really nice end right here. So this end, I can actually go ahead and put onto my solid state voltage regulator. This is going to go to the switches. I can go ahead and put this right here. All right, so that's nice and snug in there. Snug that up. This one does have power on it, so you want to make sure that this is torqued more snugly than these. So since I know I want to go from terminal 28 and terminal 18 over here to my solid state voltage regulator, I've cut 2 wires that are about the right length, just short little jumpers, and I've gone ahead and I've stripped the ends off of one of the sides. I'm going to go ahead and strip the other ends off. So again, lining up with the 16. All right, so I have this end here, and then lining up with the 16. I'm going to strip this end off here. All right, so 2 of these ends are stripped a little bit less than the others, and that's kind of on purpose. If I were to, so what I'm doing now is I'm just twisting these together, and I want to see how far that goes in. That's about all the further this goes in. So that is really the correct distance for this wire right here. This wire I'm looking at, it's just a little long. So what I'm going to do is I'm going to take my wire cutters and I'm going to snip just a little bit off of that tip. All right, so to get this wire in here, I'm going to hold that in place. Hold that in place and tighten this down. All right, number 28. I'm also going to put this in here. All right, and tighten this terminal down. Okay, so these are conducting power, so we want to make sure they are nice and snug. It's a little hard to do with this little teeny tiny screwdriver that they supplied us with, but I'm going to make it work and just get these nice and snug. Okay. All right, so we know these wires then need to come over here to this terminal on the solid state voltage regulator. But I'm not going to connect them yet because I want to get some of the other wires connected here first. It's easier to work with this thing without it tied in. Okay, so we also know that we need to go from here to terminal A1 to power this. So I'm going to get out the wire again. All right, and I'm going to go from terminal. I want it to go over to about here. So I'm going to leave a little bit extra, and this is what I'm going to cut right here. So I'm going to cut this one, and then I'm going to take just a little off because this is going to be the one that goes into the switch. Okay, so this one is really not transmitting a lot of power, so I don't have to be super torquing it. I want to get it snug. All right, so I got that in there. All right, nice and snug. Okay. And then the other end, this other end is going over here. So I'm going to give that a decent sized lead. Maybe a little bit more than that. Okay. That looks good. Twist this wire up. Okay. All right, and then I said that we also need another wire that goes from terminal A2 over to the common. So I'm just going to line this one up. Looks like about right here. This one's a little bit longer, so I'll give it just another ½ inch or so. This is going to be the side that I'm going to put on the terminal, the common, so I'll make that a little bit longer. And then this one is going to go onto the relay. So I'm going to cut this one like this. And maybe just a little bit more. Okay. All right, so I'm going to twist this up. Pull that piece of insulation off. All right, twist this one. Twist this one. All right, so let's put A2 into here and tighten down. All right, so now we have A1 and A2 are going to run up here. We're going to have these jumping over here. So now we need to run from this to terminal 25 and 15. So I can hold that up there, and I think I need about, I'll give myself about that much space. Pull this back, cut it here. I'm going to cut it on the other side here. Strip these two wires. Going into the terminal. Okay, this side's going to be a little bit less because this is going to go into the timer. It needs to be a little bit more than that. Okay. Oh, and it looks like I accidentally clipped off some of those, so I'm going to cut that off and restrip this. All right, perfect. All right, so we got one wire ready. We'll get this one ready. Okay, that looks like good length there. And I did the same thing here. All right, a little bit more. Okay. Twist this up and twist this up. Okay. So let's get these connected. Terminal 25 and 15. All right. Putting this into 25. Make that tight. All right, and then we put this one into 15. Make that tight. All right, I'm double checking all these, make sure I got them really snug, because this is going to be where some power is coming through. Okay, and I'll snug up the A1 and just make sure A2 is snug. Okay, all right, so now we have a little rat's nest of wire here. Okay, so I'm ready to wire up terminal 25 and 15, as well as terminal A1 to the power, and specifically the power that comes on when it is calling for heat. Okay, so to connect these three, it's kind of a tight spot. Gonna fan these out, twist these two wires together. All right, I should be able to push that in. Push that in under the one side of this little block. All right, got that in there. Twist those out of the way. Let me get this in. This in on the other side of the block. Okay, and that's ready to go. I want to get this nice and tight, but I'm going to be mindful that I don't want to break this, but I want to have it, make sure it's secure, make sure nothing's pulling out. It's in there good, because this is where our power is going to go. All right, so those are connected there. So I got A1, 25, and 15. So now let me run my power over to solid state voltage regulator, since I'm right here. Actually, I'm going to use the straight screwdriver. These I'm just going to slide in on either side. Hold those in place while I snug it up. I'm going to loosen it up a little bit so I can put this one in a little further. Okay. All right, this nice and snug. All right, and just gonna check those both. Okay, a little bit more on this one. All right, so this is wired up. So now I can put the finger guard back on here. So that prevents somebody from actually touching the terminals if this were in a power panel that you might be troubleshooting in. So now I have the A2, and this one needs to go up to the common. So we said before that this one right here, this white one, this is our common, this terminal right here. So I will loosen this up a little bit. All right. So now we have everything wired so that power, when it's calling for heat, power comes out of here, powers terminal A1 to power the timer, goes to terminal 25 and 15. When the timer opens up, power will go out of 28 and 18, which is a normally open circuit, which will run over to our solid state voltage regulator. The rheostat determines the voltage output from the regulator. The voltage will then travel to the two switches, which can independently turn on the 1000 watt and 500 watt heating elements below. Okay, so we have everything wired up. I have the brew kettle plugged back in. I'm gonna go ahead and turn it on. All right, so immediately we see the green light is solid on our timer, and the red light is flashing off slightly, but on longer than it is off. So that indicates power is being applied. So if I come over here and I turn on one of my switches, I'm not seeing anything. So one of the things I'm going to check real quick is the rheostat. Now remember I said that I wanted it set at 10%. But I'm going to take it up just a little bit. Let's move it up to about 20%. The rheostat might be a little finicky. So let's go back over here. I'm looking for this timer to click on again. Okay, so we've adjusted the thermostat. The timer has kicked back on, and now I can come over here and I can see that we have a faint light. So we are actually heating. So I'm going to turn that off. So everything is working as it's supposed to be. It just looks like this rheostat is not quite calibrated exactly like my others. It looks like this one's going to need about 20% to get the solid state voltage regulator moving. All right, so everything looks good. It's working. If I walk around to this side, we were heating for just a little bit. I'm gonna stick my hand in there, and it does feel slightly warmer than ambient. So I'm gonna go ahead and I'm gonna turn these on. And we're gonna wait for this to kick on. Okay, so the timer's kicked on, and what I actually had to do as well was I had to up the set point. So I think we're heating inside. I'm gonna reach my hand in, and yes, it's a little warm. So we are good to go. I'm gonna flip these off real quick. I'm gonna turn this off, and I'm gonna go ahead and unplug. So now with everything wired up, everything working as it should electrically, we just need to get these components put in there, packaged nicely so that we can put the bottom back on, install our valve, and begin using this tank. Okay, so I've got out a bunch of cable ties, and I'm going to start by connecting two of the cable ties together to give me a little bit more length. All right, I'm going to run this cable tie through here. and I'm going to run this up in here, and basically I'm just going to give myself a little bit on either side here. All right, I'm going to repeat this again over here. Get that in, run this one down, and up here. All right, so what this is doing is this is wrapped between the two fins here. All right, so this is giving me something that I can anchor to. All right, so now I want to take this guy here. All right, and probably need 2 of these again. All right, so I want to go through here like this. All right, and I want to come up under these wires here. All right, and down onto this guy here. All right, so if I tighten this up a little bit, and tighten this one up over here. What I've done is I've just kind of cinched this guy to the side of the heatsink here. Okay. All right, so that looks good. These I can tighten up just a little bit. Let's clean this stuff up. So I'm just going to cut these off. Careful not to cut our wires. Okay, so we have that trimmed up nicely. All right, so now let's go ahead look at packaging this inside here. All right, so we want this about right in here. All right, so now what we're going to do is we're going to take, I got this right here. Connected to these. All right, I'm going to thread on another right here. All right, so we can see that. Keep the view up a little bit. All right, so now I'm going to run it up over this right here. And where's our end right here? All right. Now we have this guy right here. All right, we don't want to stretch this too much because this needs to still be able to move back. Get the screw in. All right, so it looks like I need one more cable than what I had pulled out. So for this side, I'm going to run these down here the same way. All right, we have it under here. All right, let's just make sure we avoid tangling too many wires. All right. All right, and that's going to be pretty secure. Just going to sit up in there like that. Since the bottling tank isn't going to be moving around, don't have to be too concerned with it coming loose or flopping around. All right, and as that touches, it's gonna tighten up. Okay, so with those in there like that, let's go ahead. I'm just gonna clean up these right here. I'm gonna leave a little on in case I need to tighten up that later. Give me something to grab a hold of. But that's looking good. So let's go ahead and throw our bottom back on. I'm gonna loop this wire in over here so it's not in the way. And let's see. Oop. Don't want that to be in the way. All right. All right, so this is looking good right here. Okay. All right. Okay, so one thing that I've learned when taking these things apart is that if I want my display closer to where the valve is, you can actually, while the bottom is off, you can rotate it around. Now, while I've been working on it, I've kind of done that, but this little lower cylinder here, this will slip back and forth. So you see, I can spin it the other way, and I can spin it back. So I'm going to leave it spun back because I want my valve closest to my display. The way it comes, it's a little tilted over the other way. Okay, so with everything lined up where I want it to be, it's time to put in the screws to the bottom. So I'm going to take the screws, and to get them lined up, I'm just going to carefully take this flathead screwdriver, and I'm going to push those little tabs back up into place, and I'm going to try to thread the screw in by hand. There we go. Okay, so that tab's lined up. So now I have to take a look over here. Okay, so the screw is good. All right, so that one's lined up. And I would caution, you're working a little blind, so it can be a little frustrating. Just take your time. This one seems to be lined up okay. Okay, so now that I have them all started, to help me screw it in easier so I'm not fighting with the thing there, I'm going to bring these back. I'm going to bring this back closer to the end, and I'm going to start screwing them in. You got to remember, these are long screws, so there's a lot to thread in there. So I'm trying to do each one kind of even with the others. Make sure it's locked in. I'm going to give it a nice firm push with the cylinder to make sure. So you can see right here, it's Seems like that isn't in all the way, so that needs to be a little tighter. Okay. So now that the bottom cylinder is tight on the kettle, I just want to look at these, the placement of the screws here. I'm going to see if I can kick the bottom around a little bit, because when I'm tipping up the tank to try to get the last little bit out, it's helpful to have these more centered around your fill spout, so that you can put an empty soda bottle or something on the backhand side to hold it up while you're trying to drain the tank out all the way. So with that flipped over there like that, I'm going to go ahead and screw these down. Okay, so that's snug. Snug. And snug. Okay. So now I'm going to tip it up, and I just want to check all the way around that everything is nice and flush, and it is. And it looks like this little staining is from the factory. All right. So that looks pretty good. One thing to show is if you look in here carefully, you can see your timing circuit there. So with the way I've positioned it, you can get your screwdriver or another screwdriver in there enough to be able to adjust your timing circuit if you find that 30 seconds on, 30 seconds off is not enough. Or if you want to take it back up to on all the time in order to try to boil some water in there faster to clean out your tank between batches of honey. So when we started out, we had the lid and the valve. So this valve is pretty cool. It gives you the option to have a threaded hose on there if you want to try to find a hose that size. It gives you this barb fitting if you're doing just water and you want to run it with a little hose to the sink. What I've done with these in the past is I've also used them to heat up water to make sugar syrup. So putting a little barb fitting on there and being able to have a hose to fill some gallon jugs, 3-gallon jugs of sugar syrup is kind of nice. But I don't use this for filling honey. So to get the valve installed, there's a nut on the back here. Take this off. There's a little silicone O-ring right here. You want to be careful with that. And then see how the nut went on like this. The nut just goes on the inside and threaded onto the valve. Now I have never used a wrench on this, so what I do is I'll just turn it in place and I'll hold the nut with my hand and I'll spin the valve on a little bit. But I've never had to use a wrench to keep these tight. It's never leaked. And that's it. So closed, open. So I've also found the lid that we took off at the beginning. And I want to install the handle on the lid. So that thread goes up there. There's 2 7mm nuts that go on. Now remember, this is glass, so I'm just using this wrench to help me turn the nut. A little bit easier than trying to get it with my fingers, but I'm not making it very tight, and I'm not going to put a screwdriver on there and crank it down because I don't want to break the glass. So that's about it. Now you have this little cap nut that can go on top. And then just by snugging this down on the other nut, it's not going to back. And I can feel the screw turning a little bit on the bottom, but as you can see, this is nice and secure. It's not going anywhere. So the lid is ready. Okay, so with the lid assembled, our build is complete. This thing is ready to be cleaned out with some good soapy water and rinse thoroughly so that you don't get any of that soap in your honey. You do want to wash it because it's been through the manufacturing process, and there's probably some oils and other forming agents for the metal that may be on there. So give it a really good wash. Make sure that you run the water through the valve to rinse out the valve as well, both soap and then really good rinse. And make sure, since it is a ball valve, there are some small cavities in the back. Make sure you open and close the valve quite a bit while you're both running some soapy water through and your rinses. The only thing really left to add is some insulation. I have used the Neoprene insulating jackets that they sell for these. They are kind of form-fitted for it. You got the notch for the valve, notch for the handle. They are a pain in the butt to put on, so you may need a lot of patience yourself or a hand from somebody else to get these things stretched around and Velcroed tight. But it will reduce the amount of times your heater is cycling on and off. So it's a good thing. If you make your own insulation, just keep in mind you don't want to go down below the level of where the actual volume of the tank is. The instruments inside, all the wiring, everything needs to be ventilated a little bit. There are vents on the back. Make sure you don't block these up. And that's about it. So if you have any questions, anything that I may have left out or something you need clarification on, please feel free to add that to the comments section, and I'll do my best to answer any of your questions. If you subscribe, I may be putting out some videos on some of my other beekeeping innovations later on, so I hope you'll potentially watch those as well. You might also get exposed to some of my scuba diving videos for my other hobby. Thank you for watching, and I hope you have fun building your own heated bottling tank for your honey. Take care. Bye.